In this video, we're going to talk about graphing points, lines, and planes in three-dimensional space. Okay, so I want to begin by just comparing two-dimensional graphs and three-dimensional graphs in terms of what does our coordinate system look like. So the two-dimensional coordinate system, you've been using this in all of your math classes pretty much up until this point, maybe since as early as middle school. So this involves drawing an XY plane, or so our x-axis and our y-axis. Oh, okay, let me draw that a little bit better. So vertical line for the y-axis, still not great, but horizontal line for the x-axis, so x and a y. Okay, and now with the three-dimensional coordinate system, we are going to have three axes. We'll have an x, a y, and a z. So I'm going to refer to this as x, y, z space because it's no longer just a two-dimensional plane. Now it exists in three-dimensional space. Okay, so graphing this, so the way we graph the three axes and make them look, make it look three-dimensional is I'm going to draw a vertical axis here to represent z, a perpendicular one like this to represent y, and so far I'm just drawing, this is the positive y-axis, that's the positive z-axis. But now to make it look three-dimensional, I want to draw the x-axis going out at a slant. And that's the key to making it look three-dimensional. And again, so I've only drawn the positive direction for all of these so far. In a lot of graphing situations, it's enough to just draw the positive directions, especially if I don't have any points with negative coordinates. But if I wanted to draw the negative axes, it's a common convention is to do it with like a dashed line. So this would be the negative x-axis, just sort of extending into the page. The negative z-axis would be straight down, and the negative y-axis would be straight to the left. Okay, so one of the conventions with the xyz space is that it needs to satisfy, the axes need to satisfy what's called the right-hand rule. And the right-hand rule sort of specifies what orientation the x, the y, and the z axes can have. So I can't just put the x, y, and the z in any order that I want. They have to satisfy the right-hand rule. So the right-hand rule says I'm going to do my best to draw a picture of a hand here. So I'm going to start to draw a hand. Okay, so I'll have some fingers, a second finger, a third finger, a fourth finger. So imagine this is the beginnings of a hand. So the fingers are pointing in the direction of the x-axis. So point fingers in the positive x direction. Then the next thing that we do is we curl them, curl fingers towards the y. Let me give myself more room, towards the y-axis. Okay, so we would be, so notice also I haven't drawn a thumb here. In fact, I'm deliberately sort of leaving that to the end. So if I curl these fingers now in the direction of the y-axis, I'd be curling them this way. So as I do that, if we stick out our thumb, so imagine that our thumb would be somewhere here. Oops, let's put this in gray. Our thumb would be somewhere here, and if we stick out our thumb, that thumb needs to point in the direction of the z-axis. So there is the thumb. Let me draw a little bit bigger. There's the thumb. Thumb points in direction of the positive z-axis. So that's what the right-hand rule says. And the key reason we need the right-hand rule is if we don't have it, so otherwise, there's something called the cross product that we will talk about later in this chapter. Doesn't work. Okay, so now that we know what the x, y, z axes in 3D space look like, let's graph some things. So let's begin by graphing, in part A, just a point in 3D space, so the point 1, 2, 3. Okay, so I'm going to begin by drawing my axes. So I'll have my z-axis going up, my y-axis going to the right, and my x-axis coming diagonally out of the page. So x-axis. Okay, and I need to, so the way I read this is my x-coordinate, that's my y-coordinate, that's my z-coordinate. Okay, so I need to go 1 in the x direction. So imagine this is 1 in the x direction, and maybe this is 2 in the x direction. And then I need to go 2 in the y direction. So imagine this is 1 in the y direction, maybe 2 in the y direction, 3 in the y direction. Okay, so what I will do now is, and then also I need to go 3 in the z direction. So let me just indicate that. 1, 2, 3. So here's how I draw this in 3D space. So I'm going to begin with the fact that we have to go 1 in the x direction. So that sort of puts me here if we go 1 in the x direction. So that, just as a point, is 1, 0, 0. And now, from there, I'm going to go 2 in the y direction. So to go 2 in the y direction, I'm going to start to draw a line that's sort of parallel to the y-axis. And now where y equals 2 is here, so where this point is, I'm going to start to draw a line that's parallel to the x-axis. So this one needs to be slanted. Okay, and where they intersect, now I have gone 1 in the x direction and 2 in the y direction. So this point is 1, 2, 0. And from here, I need to go up 3. So to draw that to scale, this is what I do. At my z value, which is 3, I am going to make a horizontal line, so parallel to the y-axis, until I reach whatever y value I need to be at, which is 2. And then I'll draw a vertical line up until I meet that horizontal line. Okay, and what I'm going to do is I'm going to start to draw like a rectangular solid here. Okay, so now I'm going to draw a line up from 1 to 0. And I need this to have the same height that this did, because this had a height of 3. So I need this other line that I just drew here, this one right here, I need that to have a height of 3. And the easiest way to sort of ensure that is whatever point I reach here at the top, that when I draw a line connecting that point and this corner point, that's parallel to the x-axis. And now I could finish my rectangular solid. So I'll draw a horizontal line until I get to over this initial point where 1, 0, 0 was. Okay, and then I'll connect this corner point back with this back corner on the z-axis. Okay, so the point that I wanted to draw was this one right here, because this vertical distance was 3. So that is my point, 1, 2, 3. That's where it is. So drawing this sort of rectangular solid, I tried my best to make it look three-dimensional, helps us identify where our points are in 3D space. All right. So now let's do another graphing problem. Let's draw the graph of y equals 3. So to help us motivate what this is going to look like in x, y, z space, in 3D space, I also want to draw it in the xy plane. So just as a two-dimensional graph. Okay, so when we think about y equals 3, even just in the xy plane, what y equals 3 refers to is, well, every single point on this graph, all the points on this have the property where the y coordinate is 3. So what does that look like graphically? So if I draw my x, y axes, so I have my x-axis and my y-axis. Okay, now if I put a tick mark where y is 3, I need to draw all the points where the y coordinate is 3. And that's just a horizontal line. Okay, so that is the graph of y equals 3 in just the xy plane, in this two-dimensional space. Okay, so I'm going to make some comments about this that'll generalize to when I draw the 3D picture. Okay, so the first is, when I have the equation y equals 3, notice that it doesn't describe what x is. That means that x is what's called free. It is a free variable, and that means that it can be anything. And that's what we're seeing on this horizontal line. If I were to take a point like this, or a point like this, or a point like this, if I were to take all the points across this line, x can be anything, as long as y is 3. And the other key thing that I want to point out about this line is this line is parallel to the x-axis. And that's because y is fixed as this number, while x is allowed to be anything, and that produces this line that's parallel to the x-axis. All right, so now let's try to draw this in XYZ space, so in 3D space. So I'm going to draw my axes, so let me draw x. The x-axis is the slanted one. I'll draw the y-axis going out to the right, and the z-axis going up. So far I haven't really needed to draw any of the negative directions for these axes, like the negative x direction, or negative y, or negative z. Those are things that we'll put into the picture as we need them. But even for this, because y is just a positive number here, it's just 3, we may not need it in this picture. Okay, so we are trying to draw y equals 3. But notice that there's no x and there's no z in this equation, which means that x and z are both free. So x is free and z is free. So the fact that 2 of my variables are free here means that, so if I put a tick mark where y is 3, what we'll get, because 2 variables are free, is we'll get a 2-dimensional object. We're actually going to get a plane here. So to see that, let me just begin by drawing the line where y equals 3 that just goes through this point. So that line, to draw the line where y equals 3, it needs to be parallel to the x-axis, just like this one was in 2D space. So I'm going to draw a line that goes through y equals 3 that's parallel to that x-axis. Okay, and now both x and z can be anything. So on this line that I've drawn, x can be anything. X can be really, really negative over here, or x can be really, really positive on this side of it. But I also need to consider the fact that z can be anything. So I need to be able to go up or down directly above this line or directly below this line. So how I draw that is, so I'm going to draw a vertical line up here, another vertical line up here, and I'm going to connect them. I want to make them the same height so it looks 3-dimensional. Cool. And let's also extend it down, because z could be a negative number. So if I extend this down, and I extend this one down, and then we connect those, we start to get a sense of what this plane looks like. Okay, so what we have is, we have this, let's write this here, we have this plane that is parallel to, and what is it parallel to? It's going to be parallel to the xz plane, the plane that's formed, that's sort of spanned by the x and the z axis. Okay, so that is one key property of this. And the other thing is, it's harder to show this visually, but this plane extends infinitely. So it looks like in my picture that I've just drawn this sort of like rectangle, but just imagine that this rectangle extends infinitely. So it goes infinitely high, infinitely low, infinitely sort of like forward into the, out of the page, and infinitely back. And that kind of mirrors what happens with the line, because the line doesn't stop. We draw these arrows to indicate, oh, it keeps going. It's harder to do that with a plane. It's harder to draw arrows to indicate that it keeps going forever. So we have to just visualize that. All right, so let's do another example. Okay, part C. Now I want to draw y equals -2 and x equals 1. So there are 2 conditions that I need to satisfy. So there's no z being described, which means that this means that z is free. So z is going to be allowed to be whatever we want. So let's draw our axes. So we'll have a z-axis, an x-axis coming out of the page, and a y-axis. Okay, and this time I do have a negative coordinate. Y is -2. So I'm going to draw my negative axes for this. So negative x-axis would go into the page, negative z-axis would go down, negative y-axis would extend here to the left. Okay, so let's begin by figuring out where, let's go 1 in the x direction. So x is 1, let's go 1 in the x direction. And let's go -2 in the y direction. That would be, so let's say this is -1, and maybe this is -2. So let's just see where that would take us if we go 1 in the x direction, and then -2 in the y direction. So I'm going to start to draw a line through where this point is, where x equals 1 here on the x-axis, parallel to the y-axis. And then starting at -2 on the y-axis, I'm going to draw a line that's parallel to the x-axis. Okay, and then where they intersect. Where they intersect here, whoops. Where they intersect, that is the point. Oops, it is, sorry. The x-coordinate's 1, the y-coordinate is -2, and z is 0. So the fact that z is free, the fact that z is anything means not only can it be 0, so where we are at this point, but I can go straight up or straight down as long as I keep the x-coordinate 1 and the y-coordinate -2. So that means I could go straight up and just increase the z values. I could also go straight down and decrease the z values. And what that produces is a line. So the graph is a line that goes through this point 1, -2, 0. All right, so let's do another example. So part D, now I want to graph x equals 0, y equals 0, and z equals 0. And these are 3 separate things. So these are actually 3 separate problems. I want to graph x equals 0, see what that looks like. Graph y equals 0, see what that looks like, and z equals 0 separately. So if x equals 0, that means that the other variables are not present here. So y and z are free. So y and z are free. Okay, so what I'm going to do now is I am going to draw my axes. And this time I'm going to draw them slightly angled. So the z-axis, I'll keep it this way. The x-axis, I'll keep it angling out this way. But the y-axis, instead of drawing it straight out to the right, I will also angle the y-axis a little bit this way. It turns out it's going to be a little bit easier for this particular graph to visualize this if I also angle my y-axis. At least that's what I have found. Okay, so let me just start it off like this. All right, so let's also draw the negative axes this time. So the negative z-axis will go straight down. Negative x-axis would sort of extend this way. And the negative y-axis would extend this way, sort of diagonally to the left. We really try to think about this as being like a 3-dimensional thing. It's being able to visualize these things is perhaps the trickiest part of making this transition to three-dimensional space. But really putting in the time to practice this and really try to get a good visual sense of what's going on is going to be helpful. So what we know about the points that are on this graph is that x needs to be 0. So here's one point where x is 0. Basically, I could have any point where x is 0. So I can't have any point that's like out here where I have a positive x coordinate. Let me erase that. Or way over here where I have like a negative x coordinate. The x coordinate needs to be positive. And what that's going to mean is that our graph is actually the y-z plane. I have to be on the plane formed by the y and the z axes. So here's how I'm going to start to draw that. So I'm going to take a point that's on the z-axis, and I'm going to draw a line through this that's parallel to the y-axis. So I'm going to try to form like a rectangle shape that sort of will look like it's the yz plane. Okay, and now I'm going to draw lines through these endpoints, so one here and one here, that are parallel to the z-axis. So let's go straight down, parallel to the z-axis. Let's also go straight down here, parallel to the z-axis. Let's try to do the same length. And now let's connect the bottoms of those two things with a line that's parallel to the y-axis. So really trying to draw these things parallel to the y-axis, to the z-axis, is super key in trying to make a good 3D picture. I'm not great at this, I'm just trying to do the best I can. Okay, all right, so now just to help us visualize this a little bit more, think about this. So this needs to extend forever, infinitely. But so here is just like, you know, the x-axis, negative x-axis peeking out behind it. Here would be the y-axis sort of extending further this way. Okay, but that's what this graph looks like. Now let's do where y equals 0. So With this one, there's no x or z, which means x and z are free. And in the same way that when x equals 0, we got the yz plane. When y equals 0, we are going to get, because x and z are free now, and y is 0, we are actually going to get the xz plane. And we might also be able to see what we're going to get with z equals 0. But let's try to draw this. So I'm going to, again, draw sort of angled, slightly angled axes. So z straight up, x out here, and then y slightly angled. And I'll draw some negative axes, so negative z, let's go negative x, and negative y. Okay, so now this time y needs to be 0. So again, I'll sort of start it off with the origin, and that's a point where y equals 0. But I can't have a point like here, where y is positive. That would be bad. I also can't have a point like here, where y is negative. That would be bad. Y has to be 0, which is what forces us to be on the xz plane. So I'm going to draw this in a very similar way. Because I'm on the xz plane, let me start off by taking a point on the z-axis. And to draw my xz plane, or at least to try to, do my best, let's draw a line through this point that's parallel to the x-axis. So parallel to the x-axis would look something like this. Now at those endpoints, let me draw lines straight down that are parallel to the z-axis. So straight down, parallel to the z, straight down, parallel to z. And now from these endpoints at the bottom, let's draw a connecting line that's parallel to the x-axis. So that would be something like this. Okay, so really try to visualize that this is the xz plane. Okay, so sort of peeking out behind this, we'd have the negative y-axis. Extending this way, we'd have the negative x-axis. Alrighty. Okay, so there's one more of these. So when z equals 0, now x and y are free, and we are going to get the xy plane. So this one I'm going to draw more quickly. So we got our z-axis vertically, x-axis angled out here, and then y-axis I'm going to keep it angled. Let's draw some negative axes straight down for the z, this way for the negative x, this way for the negative y. Okay, because I need to be on the xy plane now, I'm going to start off with a point that's just on the y-axis. And I'm going to draw a line through that parallel to the x-axis. So parallel to the x-axis looks something like this, something like that. And now through these endpoints, I'll draw lines that are parallel to the y-axis. So parallel to the y, parallel to the y. And then let's connect those with a line that's parallel to the x. Okay, and that is our xy plane. Just imagine that it extends infinitely in all directions. So these three planes are called the coordinate planes. So just like in 2 dimensions, we have the coordinate axes, the x and the y axes. In 3 dimensions, we have coordinate planes. All right. At this point, we have talked about how to graph points, lines, and planes in 3-dimensional space. In the next video, we'll talk about how to graph 3-dimensional curves and surfaces, and then after that, we'll move on to goal 2, which will be graphing regions.